There are manifold reasons someone may take a course like this. Whatever yours are, we're going to cover some really important things in this module. We'll talk about what manifolds are, what you need to know to work on them, talk about what's going on under the hood in your medical gas manifolds. We're also going to talk about manifold room safety because we don't want to leave anyone breathless. We'll talk about how to correctly respond to the alarms that your medical gas manifold may have, how to make sure you don't have prohibited items in your manifold room, and how to get a perfect sear on a ribeye using only items you will find in every manifold room. I made that last part up, but this is still really important stuff, so stick around and let's learn about manifolds. Let's open up these manifolds and let the learning flow into your brain pipes. You're welcome. There are three different categories of manifolds that you might have in your manifold room. The first is probably the most common, which is high pressure by high pressure. That just means you have high pressure cylinders on the primary and the secondary side, and that's all you're using. The second is called a hybrid arrangement, and that's where you have a liquid container or dewar on the primary side, and then the secondary side is going to be high pressure cylinders. You will also have in that configuration a high pressure bank of reserve. The third configuration is called a liquid by liquid, in which case you have a liquid dewar for your primary, a liquid dewar for your secondary, and a high pressure reserve bank. You may notice that with the second two categories, you had a third or a reserve bank. That's just because with liquid containers, they have something called a normal evaporative rate, which just means they're constantly losing product as that liquid turns into a gas and evaporates. Because of that, in order to avoid a situation where you have a liquid container evaporating even though it's not being used by your facility demand, anytime you have a liquid container either on the primary or the secondary side, you have to have a high pressure cylinder reserve. Let's talk about the components inside these manifolds and the flow of gas from the containers or cylinders into the manifold and then into the pipeline. This is how our gas is stored and delivered. It's going to be in a cylinder or a container. And these cylinders, which are high pressure, usually the pressure is around 2,000 psi, go through the cylinder valve. This is how you turn these cylinders on and off. And then through this hose, which is called a pigtail. Now, these are stainless steel because this is carbon dioxide. Usually with any gas other than oxygen, they're going to be stainless steel because they're just a lot easier to work with. Code requires oxygen pigtails to be copper, rigid copper. So serve the same function. They're just a little bit harder to manage and you have to replace them more often. Typical recommended replacement frequency is 5 years for these guys, 3 years for copper. So our gas is going through the pigtail. Right here on the header bar, there is a check valve, and then it goes into the header bar, through this header isolation valve and into the manifold. The check valves may be in different locations depending on your specific manifold. Sometimes they're actually on the cylinder end, sometimes they're on the header bar end of the pigtail, and then often they're a permanent part of the header itself. That way when you replace your pigtails, you can leave the check valves in place. So our gas is going to go through this header isolation valve. These are typically used for significant service only. If you're shutting down half the manifold to replace components, you can use these guys. You don't really want to mess with them during cylinder change out or other normal operations. We're going to take the cover off and show you what's under the hood in this manifold.
What is a manifold? Manifold, meaning many things together, goes back to 1969 when Leonardo da Vinci created his first flying machine made of gases and pipes. And that's how the valves and pipes came together to form a manifold in your building.
So continuing the flow of gas from the header bar into the manifold, first thing we're going to go through is this regulator, which is called a bank regulator. Now, manifolds have two stages of pressure reduction. So we have high pressure coming in around 2,000 psi. First stage of pressure reduction is these two regulators, the bank regulators, which are going to take us down to an intermediate pressure. So the next thing we have are the final line regulators. You may notice that for both of the regulators, there are 2. That's just because the NFPA requires full redundancy for pretty much everything involved with medical gas systems. So you have a primary and a backup. So final line regulators, this is our second stage of pressure reduction, and we're going to take the pressure from the intermediate pressure down to whatever pressure you actually need in the building, which for most gases is going to be 50 to 55 psi. So for this particular manifold, which is carbon dioxide, we've got our final line regulators here. Right before you get to those line regulators, we have 2 regulator isolation valves. You're going to use those really for normal operation, but especially for service. So if you have to close off one side of your manifold to adjust or to service regulators, that's where you do it. Next, we're going to get to these little valves up here. This is a service valve that enables you to shut off the flow of gas to either a dome bias regulator or a solenoid valve, depending on the pressure delivery range of your manifold. This is a little bleeder valve. It's also used for service. The purpose of this valve is just to simulate demand when you don't have demand and you need to work on the manifold. So for making any kind of adjustments to the regulators, those adjustments should be done under demand. And if you don't have any demand in your facility, you're going to want to simulate demand with that little bleeder valve. We also have 2 pressure relief valves. One is protecting the intermediate side of the manifold and one is protecting the line pressure side. The line pressure in these is going to be pretty uniform. Anytime you have a 50 to 55 psi gas, that's going to be a 75 psi relief. And as you can see, those are tied together into this block. From there, they should be vented outside the building. Last thing we're going to come to in this manifold is the source valve. Every manifold and pump and compressor has a source valve. As the name suggests, this is the valve that shuts off the source from the pipeline. So if you need to service or replace the entire piece of equipment, that's the valve you would close. Last thing we're going to look at with this manifold is the gauges and the alarm signals. Now, the gauges and the alarms are going to vary depending on the configuration that we already talked about. So if you have a liquid by high pressure manifold, which is called a hybrid, or a liquid by high pressure, or in this case, we have a high pressure, each of those configurations is going to have slight variances with the alarms that you need. With this manifold, which is a high pressure, you can see we have right here a changeover alarm. And that's the only alarm we're going to have from this manifold because we only have 2 sources of supply. You have a primary and a secondary. So with a high pressure manifold, when the primary supply depletes and switches over to the secondary, you get a changeover alarm right here. It doesn't alarm audibly in this room, but it will alarm audibly at your 2 master alarm panels. If you look at the gauges, this one is delivering your left bank gauge pressure. This is showing your right bank pressure. And this is showing your line delivery pressure. Depending on the version you have or the manufacturer you have, those gauges might be in slightly different places, but most manifolds are going to have 3 gauges. The outsides are always going to be the bank pressures, and the middle one is going to be the line pressure.